Just gonna wait for a few more minutes. We will start at 7:05. Yeah. If you miss a class or if your Wi-Fi cuts out or something and you just have to log off or you have to just leave early, yeah, all of the recorded classes will be on YouTube. So it's 7:04. Let's get started. Hi, my name is Siddhartha. You can call me Sid. I'm a rising junior here in Westminster Plainsboro High School South at New Jersey. And yeah, this is Geometry in AMC 8. This class will run weekly until November 10th, Fridays, 7 to 8, same time. Um, and just to get the logistics over with, if you have any questions during class, you can always just ask me in the chat, and I'll try to answer them to the best of my ability, because chances are, if you have a question, then others are going to have a question as well, and others might benefit from hearing that question as well. And homework will be posted after each session. Please try your best to do them, because I believe that if you just watch me rant about it and just don't do anything about it, maybe you'll learn like 20% of the content if you like really listen. But if you do problems, and if you like apply your knowledge to different problems, you'll just improve that way, and your concepts will also get stronger. And so yeah, just try to do the homework, and if you can, then at least just please turn in a numerical answer, just so that I know that you've attempted the homework. And I'll make a Google Classroom assignment after each class, each night, so that you can turn in the assignment. And as I mentioned earlier, Nishant, all the recorded lectures will be on the Alphademic YouTube channel, so consider subscribing. And Also, on the homework problems, if you have a question, or like just if you have a question, you can message me anytime on my Gmail, and I'll just tell you my Gmail after the end of, or I'll just post it in the chat right now. It's yeah, so that's my email. You can email me anytime, and I will try to get back to you in 2 days. I can't guarantee an immediate response, but in 2 days, I think I'm gonna try my best to get back to you. And most importantly, try to uh that's a good question. So Nishant's asking, does this class follow the ops geometry textbook? Well, sort of. It takes concepts from the ops geometry textbooks, but some of the problems you won't see on the ops geometry textbook, and also like I've just like picked my own problems as well. So it's not totally, but yeah, some of the concepts are on the ops introduction to geometry textbook. And most importantly, like try to have fun, and I hope you like learn and take away something from this class. uh so today's class, if you looked on the syllabus, is on angle chasing. And so just to get a few terminologies over, so say I have two rays, right? And say this point is, I don't know, A, right? This point is B, and this point is C. So this is called an angle. And the point B is called the vertex of the angle. And so also, just if you guys have seen this before, then this is a more of like a this is more of like a notation thing, but some people really get confused on it sometimes, and it can be a bit confusing. So I'm gonna go over it. If I want to label this angle, does anyone know how I label this angle in terms of like angle? Like, anyone know the notation of naming this angle? Yeah. So exactly. So you label this angle as angle ABC or angle CBA. Either way works, but you just have to keep the vertex of the angle at the middle, right? So here you see the vertex is at B. So you keep the angle vertex at the middle. Or you can write it also as angle CBA, which is both work perfectly fine. Yeah. And make sure you get this down because this is really important. If you label your angle any other way, it's gonna be wrong, and you're probably gonna end up getting the problem wrong. So try to remember this, and like, I mean, it's kind of straightforward anyway, but it's a pretty important concept when you're learning about angles. Uh, so now I'm just gonna be going over more terminologies. Uh, if I have a By the way, this line, so this angle ABC, uh, this is called a perpendicular. These two lines are perpendicular to each other. Does anyone know what the angle ABC is? Yeah, exactly, 90 degrees. Yeah, so whenever the two perpendicular lines meet at a vertex, that vertex angle is always 90 degrees. And so now we're gonna go over a example problem. So the problem goes like this. If say this is A, sorry, my pen says wacky, right? And say say this is 40 degrees, and this is a random X, right? And this angle ABC is 60 degrees. Anyone know what X will be? Yeah, it'll be 20. So this, by the way, just another terminology. Angle ABD from right here and angle DBC. These two angles are called adjacent angles. I mean, the name kind of says it for itself, but whenever two angles are beside each other, they're called adjacent angles. And also, if this is 40 degrees, if this is like 20, maybe say, right? And if I want to measure this angle, anyone know what that is? Yeah, that's 340. This is 340. And anyone know what the name of the angle that's greater than uh close? It's not an exterior angle. It's called a reflex angle. It's the terminology is not too important here as long as you know that like as long as you know that the some of the angles are at 360. The terminology is not too important here, but like whenever you have angles that are like greater than 180, as in this case, this angle is called the reflex angle. And yeah. Basically, you see so going back to adjacent angles, you see how line BD here, you see how this angle ABD and angle DBC both share the line BD. they both share the side BD. Whenever two angles share a side, it's called an adjacent angle, basically beside each other. But being more technical, if they share a side, then the angles are adjacent. So here, angle ABD and angle DBC, sorry. Yeah, okay, great. So coming back to exterior angles, so first let's go over another example. So everyone know, like, you guys know what the angle of a circle is, right? Like in this problem, like the angle was 360 exactly. Um so basically, I'm now gonna draw a line, right? Say it's called line A B ABC, right? And I draw a circle. Sorry, not a very perfect circle. I'm not a very good artist, but so if I draw an angle ABC, if I draw a circle ABC, uh, and by the way, B is the center of the circle, and this is a straight line. So can anyone tell me what the measure of angle ABC is? Yeah, yeah, Selena, that's right, and Nishant, that's also right. It's 180 because you see, in this argument, by the way, it's because B is at the center, right? And angle ABC is a straight line, so it cuts the circle in half. And you know that the total measure of the angle is 360, right? So this is 180 over here. Sorry, my pen is being wacky. And similar to this. So exactly 360 over 2, because it cuts the circle in half. So that's why it's a 180-degree angle. And well, this is kind of self-explanatory, but this angle, by the way, is called a straight angle. By the way, I'm just introducing these terminologies, but that doesn't mean these are important to memorize. Only some of, like, the terminologies are not very important to memorize. If you know what to do with the angles, then you're gonna be fine. Like, no competition is ever gonna ask you what is an angle that, like, what is the name of an angle that has a measure of 180-degree called, or lies in a straight line called. That's a straight angle, but no competition is ever gonna ask you that. So it's not very important to memorize the terminologies, but it's important to memorize. It's important to know actually what the angle does. So that's mainly what I have to emphasize here. And yeah, so now if I have a straight line, and if I have a ray like this, if this is 55, if making the numbers better, if this is 60, then this angle is easy to figure out, right? This is, yeah, 120, because using the other slides, uh this is a straight, using the other slides logic, this is a straight angle. So it lies in a straight line, so the sum of the angles are going to add up to 180. So if this is 60, then you get 180 minus 60, which is 120. Yeah, that's so. Now that we have all this out of the way, I'm going to draw two intersecting lines, right? And say this angle, I say this is maybe 30 degrees, right? Anyone know what this angle will be? Yeah, it's a it's yeah, I was gonna get to that terminology later, but yeah, it's called a vertical angle, so it'll be 30 degrees as well. And you can either remember it as a vertical angle and you can say that they're equal, but the other way to do it is the more rigorous way to do it. Actually, it's because is you say this is a straight line, right? So so this angle, so I'll just say this is a sorry a o b, right? So I'll just say angle AOB, right? And angle AOD, right? They have to add up to 180 because DOB is a straight line. So this angle and this angle, they're gonna add up to 180, right? So this angle is gonna be 180 minus 30, which is 150. And again, using the same logic, we know that sorry, I forgot to label this line. It's maybe it says C, right? So we know that AOC is a straight line. So again, if you do this twice again, then it's gonna be 180 minus 150, which is 30. So it has the same measure, and this is called the vertical angle. Now, more terminology here. Uh, if angle AOB is 30 degrees and angle AOD is 150, right? What are these angles called? Anyone know? Yeah, supplementary. If two angles add up to 180, they are called supplementary angles. So supplementary. This is an important terminology you should know because this shows up a lot in problem statements. So if you don't know what this means, then you won't be able to understand the problem sometimes. So supplementary is when, yeah, so I'll get to that in a bit. Supplementary is basically when 180 happen, when two angles add up to 180 degrees. And as Nishant said in the chat, complementary is when two angles add up to 90 degrees. So we have a right angle here. And if we say that this is like another line, right? Going off, this angle plus this angle is 90 degrees. So this angle will be complementary to this angle. That makes sense? So basically the adjacent angles are going to be complementary to each other. Yeah, okay. So this is complementary. I'm just gonna write column because my pen is being wacky here and I don't want to waste class time. So yeah, and that's when 90 degree happens. Yeah, okay. So we've gone over vertical angles and now we're gonna go over something called parallel lines, and here a lot of terminology is going to be introduced. So and some important things are going to be introduced. So make sure you're paying attention. So basically, if we have something like this, right? And I said this is one maybe 100 degrees, maybe 100 degrees, right? If this is parallel, this is a parallel, does anyone know what this line is called, by the way? Like the line in this line? Yeah, a transversal. A transversal is any line that basically a transversal is any line that cuts through two parallel lines, basically. And also, by the way, I'll just post these post this Jamboard later, so you guys have time to review while doing homework. So sorry. Yeah, this line is a transversal. And now going back to my original question, does anyone know what this Yeah, it is. Yeah. It is still it is still a transversal. Like any line that cuts across two parallel lines is called a transversal. Now, if it cuts the two, if it say if it cuts this into, like, if these are two parallel lines, right? And if it cuts them perpendicularly, it's still a transversal. Like, even if it cuts it in, even if it cuts it in, the angle, it doesn't matter here. It's regardless of the angle. If a line cuts two parallel lines, then it's called a transversal regardless. Makes sense? Yeah. Okay. So uh so anyone know what this angle will be if these two lines are parallel? And yeah, this will be 100 degrees. Be and anyone know what what these two angles are called? Like this, like just to make it more clear, this angle and this angle, yeah, corresponding angles. These two are corresponding angles. So corresponding angles in any any two parallel lines are always equal to each other. And so now we're going to go over alternate interior angles. And alternate interior angles here is basically like, I mean, these terminologies again are not very important to memorize, but I just feel like you guys should know this. So uh like, say I have an angle here, right? Say this, so anyone know what this angle would be? I'll just erase this just to get it out of the way. Sorry. Yeah, 80. Yeah, 80. And so say I label this angle as D. And basically alternate interior angles, this angle, right? With, like, say I label this angle G or something. D and G are alternate interior angles. Basically, the two angles that are like interior. Like what I mean by interior is basically like, you see how they're not exterior, like alternate exterior angle. Yeah, they're between both. Yeah, exactly. They're between both of the lines right here. So it's towards the interior, but they're still between both of the lines. And alternate exterior would be like this angle right here, this angle, and this angle. This would be alternate exterior because these are like towards the outside, right? But these two angles, these are towards the inside. So this will, and also, as one of you put it very nicely, it's basically what somebody said is interior means they're between both of the lines. Yeah, that's right, but then again, this is also between both of the lines. So I mean, it's not much of a difference. Just know that this angle and this angle are alternate interior and alternate exterior, and this and sorry, yeah, this angle and I'll just write it here. And this angle. These two angles are alternate exterior angles. And these two angles are alternate interior angles. Can be pretty confusing, but just know that when you have alternate exterior or alternate interior angles, they're all equal to each other. So like, so what I mean by that is if this is 100 degrees, right? If this angle is 100 degrees, this will also be 100 because this is alternate exterior. And and since D is an alternate interior angle to G, this will also be an 80-degree angle because alternate interior and alternate exterior are basically the like they're equal in measure, if that makes sense. So I'll just write it down in more detail because like my pencil is being pretty wacky today. So I'll just post it in classroom after the class session so uh you guys can go over this in more detail. But just for now, just know that alternate interior and alternate exterior angles are all equal in measure. And Yeah, so you can go over a certain example problem, which is like it's something like this. So it's basically, if I have something like this, right? And I say this is 140 degrees, right? This is from the introduction to geo book, by the way. So for whoever asked me that if this course is related to the book, yeah, this problem is from the intermediate introduction to geometry textbook, and I think it's a useful problem for us to go over. So, and then this line cuts this angle, and then this is a right angle. So I'm just so by the way, this is notation, but you just label a right angle with a square, and this angle is 3x, right? And basically, do you guys see the arrows that I've made? Do you guys know why these two lines have two arrows and these two lines have one? Like, anyone know why that's the case? It's just a notation thing, but a lot of contests just do this. So, anyone know why? Okay, it's fine. So basically, I'll just tell you guys this. It's because the yeah, it's because the it's because these two lines are parallel to each other, and these two lines are parallel to each other. But but the reason why they're marked with a different number of arrows is because if I marked it with one arrow, like if I mark this, say I mark this line with one arrow, right? I remove this arrow, like forget about this, right? I marked it with one arrow. This means that this line would have to be parallel to this line because it's marked with one arrow. So the number of lines, yeah, that's impossible. So that's why you can't like, you can't draw one arrow on this line. It's because the number of lines indicate the pair of lines that are parallel to each other. So one line means these two lines are parallel to each other. Two lines means these two lines are parallel to. Now could I have said that? Now could I have said this to three lines and this to three lines? Yeah, absolutely. Because the it's because none of the other lines have three. Because it's because these two lines don't have three arrows. These two lines have only one arrow. Now if I just can't mark these two lines with any with say like one less arrow, because if I mark these two lines with one arrow, and this would be parallel to, then this line would be parallel to this line, which is impossible, as one of you mentioned in the chat. So that can be possible. If I marked it with 3, 4, 5, yeah, sure, okay, because because these two, it just but what I'm trying to say is, just make sure the number of lines that the lines are parallel. Like if you have two pairs of lines, make sure that the number of arrows you have are different from the other two lines. Anyways, so yeah, so basically, so this line, so from what I've so now that you guys know that these two lines are parallel to each other, and so are these two lines. Can anyone tell me the value of x? I'm just gonna give you guys 5 minutes to figure out the answer. And don't just PM me if you find an answer, just because I don't want like other people get knowing the answer. So just give me a PM when you guys are finished. Oh, by the way, this is also an angle x. Yeah. Okay. So now you guys can solve it for 5 minutes. We'll discuss at exactly uh your time your at exactly 7:39 in my time, or like 5 minutes in your time. Uh, we'll discuss the problem in exactly a minute. So Do you guys need 3 more minutes? Like, would that be helpful? Please tell me in the chat or like raise your hand or like say yes in the Zoom call or something. Okay, so we'll go over the answer in 2 more minutes since some of you are still trying the problem. Okay, so Steven, you can type in the chat and I'll just like you can tell me what you did and yes, this is angle chasing. Yeah, this is a basic example of angle chasing, but yeah, this is angle chasing. Yeah, Steven, that's a good way to approach it. So basically for those of you who didn't understand what Steven was doing, basically what Steven did is he noticed that uh like he noticed that this angle, right? Uh okay, yeah. So Steven basically what he did is he noticed that he used the fact that alternate interior like these two are alternate interior angles, right? Like this angle and this angle. Do you guys see why? Like going back to the other slide. Remember how we discussed that? How we discussed like this angle is equal to this angle. It's a pretty similar approach back here. So this angle is equal to this angle. Yeah. Okay. So basically, what Steven did is he used the fact that these two angles are similar. So he said that this angle, this whole angle, this is 140. So we have 3x, right? So we have 3x here. And we know that we need this angle right here. We need this angle right here to like because we need another angle that'll make these two adjacent and like you guys agree that this is an adjacent angle to this, right? So we need this angle to be like, we need this angle to like finish the equation, right? So then Stephen noticed that this is a straight line. So the sum of the angles in a straight line, as we discussed with the circle example, is just 180. So this angle will be something like this. It'll be 180 minus this angle's length, this angle's measure, which is 90. And then we need to subtract this angle, which is x, and that gives you this angle. Because essentially what you're doing is you have this whole angle right here, and you subtract this angle. So now you're at this and so now you're here. And then you subtract this angle, and then you get this. So that's what Stephen did, and he added this term to here, and he got and he put here, and he said this equal to 140. And then you solve for x, and you get something like x equals 25, I think. Yeah. So that's essentially Stephen's logic. Is that what you did, Stephen? Yeah, I'm gonna assume that that's what he did. So hopefully you guys got something out of this problem, and this is just a problem that tied in like everything we have learned so far. Now we're gonna discuss a super important topic, which shows up in the AMC a lot. It's basically related to a triangle, right? So you guys know what the sum of the measures of the angles in a triangle is? So like this angle plus this angle plus this angle. Yeah, the sum is equal to 180. Right? And we can prove this. We can prove this. Actually, do you guys want the proof, or do you just want me to move on, because the proof will take some time? Okay, you guys want the proof? All right. So this is A, this is B, and this is C. Right? So we know that this was this, so we know that angle AB, like the sum of the angles are 180, but we'd like to prove it somehow, right? So we take a line like this. So this is a straight line. Forgive my artistic abilities. So let's say this is like J, and this is say H, right? So this is J and this is H. So let's say we have an angle here, right? And we have an angle here, right? And since this is, so basically this line right here, the line JH, right? It's these two lines are parallel to this, so it's parallel to it's parallel to BC. It's parallel to BC here. These two lines are parallel to each other. So if these two lines are parallel to each other, then what do we know about this angle and this angle? Like this one, angle HAC and angle ACB. Yeah, they're equal. They're equal. I mean, this is a pretty easy proof, but basically you can just notice that if you draw a parallel line like this, sorry, this is just the C. I'll just label it here. If you draw, now you can see that this angle and this angle is corresponding, right? Angle A, like the angle right here and the angle right here. These two lines are corresponding angles. This is going to be equal to each other, right? So this is X. This is also going to be X. But what we looked at the very beginning, these two angles are vertical, right? This angle and this angle, like we looked at it, I think somewhere. Oh my God, this is terrible. Yeah, I think we looked at it somewhere over here, I believe. Wait. Yeah. So see 30, 30. You see angle. You see these angles. It's a similar logic. So these angles are vertical. So these two angles are vertical. So this is equal to this. So I'm just gonna label it with a line right here. This is also very useful notation. You can mark angles equal by drawing a line on the angle itself. All right. So we know that angle AHC angle AHC equals sorry, not angle AHC. Yeah. It's angle AJC. Sorry. Actually, this proof is gonna take a bit of time, so I'll just upload it to Google Classroom when I upload the Jamboard, because I want to cover more content, and this proof is like it's a useful proof. So make sure you guys check it out in Google Classroom when I post the proof. But I think we should move on. Just know that the sum of the angles in a triangle are 180. Is that okay with y'all? Yeah, yeah. Okay, so we'll just move on. Basically, we'll just talk about. I think this was an AMC problem some years back. Uh, it was an AMC 8 problem. So it says that if the degree measures, if the degree measures of the angles of a triangle, right? So I have a triangle like this, and it's saying that if the degree measures of the angles of a triangle and in the ratio 3:3:4, so like if I have an x here, it's saying that the degree measures are like this, 3x. Sorry, it's saying that degree measures are like this. It's saying that the degree measures are in the length 3:4. Then what the problem is actually asking is, what is the degree measure of the largest angle of the triangle? And I'll give you like 3 minutes to figure this out. No, that's close, but not really. No. What is the degree measure of the largest angle? We know that all of the angles are 180. Now, so let's see. Yeah, you guys are right. So the largest angle is going to be 72. And basically how you do it is, as some of the people here figured out, is just, yeah, if you said a variable x, then this is basically just 3x. Then this is basically just 3x. This is also 3x. And this is 4x. Right? And because the sum of the measures of sum of the angle measures in a triangle is 180. So if you add this all up, you get 10x, because 3 plus 3 plus 4x is equal to 10x. 10x is 180. And then if you solve it, you get x equals 18 or something. And then you see that this becomes like 54. And then you see this becomes 54, and this becomes 72. This becomes 72. So the answer is 72, because that's the largest angle in the triangle. Yeah, that's right. Yeah. Also, as an as a more external fact, like this is just more of a fun fact. We haven't like covered this topic yet. I think it's like week 4 or week 3, but the triangle is called isosceles because it's in the ratio 3:3:4. But you see that these triangles are equal. Like these triangles are both 3x and 3x. So it's gonna be 54. This is also gonna be 54. So whenever the angle measures are equal, that means that whenever two angle measures equal each other, like in a triangle there are 3 angles, right? And whenever 2 angles equal each other, it's called an isosceles triangle. So yeah, good job to whoever knew that. And finally, we're going to be talking about exterior angles. So exterior angles. So basically, if we say that this is again ABC, right? This is A, this is B, this is C, and this is say D, right? But yeah, so this is D. And then basically what it's saying, what the exterior angle, what exterior angles are essentially are, is it says that angle ACB and angle ACD are exterior angles. Yeah. There is also something called the exterior angle theorem, as one of you pointed out. The exterior angle theorem basically states that these two angles together have a sum of 180. The exterior angles have a sum of 180. So basically, so now if so now that there's nothing more to exterior angles that we should explore. It's just that the sum of the interior angle, which is right here, and the angle exterior to it is just 180. And it's all important because remember, it has to lie in a straight line. If it doesn't lie in a straight line, like say BC and then D was here, right? Then this angle wouldn't be equal to this angle. Like with this angle plus this angle wouldn't be 180 because this curves right here. So the angle measure is not 180. And now we'll just go over one last problem. And then that's pretty much it for today. It's gonna be something like this. So sorry, I'm still in Bezier mode, but so this, and then I have something like this, and I have something like this, and then this, and then this, and then this is A, this is B, and then this is C, and this is, then we have another line, and then this is E, and then this is D, and then it says that this angle right here is 2x minus 20, right? And then this angle right here is x plus 55. Sorry. Right? And then this angle is 30 degrees. And then these two lines are parallel to each other. As we discussed earlier, these two lines, this arrow means it's parallel to each other. And so basically what this problem wants, it wants us to find angle CED. So does anyone remember what angle CED is? Like just in the diagram. You don't have to tell me the answer, just in the diagram where angle CED is. It's this angle, right? So you have to find this angle. So this is say Y. So I'll just give you guys like 3 minutes since we're pretty much ending, pretty much nearly coming to the end of our class. I'll just give you guys like 3 or 4 minutes just to figure it out, and then we'll go over the solution, and then that's it for today. Just find Y here. And anyone who comes up with the answer, like, can just type it in the chat or something, and then yeah. We'll go over the answer in a minute. So we'll go over the answer at 8:02 in my time, or a minute in your time, and then that's it. Yeah, no problem. Just take your time. Oh, it's 8:02. Yeah, so we'll go over the problem now. So uh basically what you do in this problem is you notice that 2x minus 20, and this is 2x minus 20 and this is 30. So you solve for this angle, and you get something like 180 degree minus the sum of these two, right? Which is 2x plus 10, because 2x minus 20 plus 30 is, I'm just gonna label it as like z, say, but z is just 2x plus 10. 2x plus 2x plus 10, right? And so if this is 180 minus z, what is this angle right here? If this is 180 minus z, then this angle is, like, the exterior angle is. In terms of z, it is just z, right? Because it lies in a straight line, and these two angles are exterior to each other. This angle and this angle, exterior angles, right? Yeah, 180. So it's just 180. So it's just the angle 180 minus 180 minus z, which is just z. So I'll just write it down here. which is equal to z here, right? So this angle is z. And remember, z equals 2x plus 10 here, right? And basically, if this is x plus 55, right? And then basically, then we can just notice that, like, so I'm just gonna let you guys see what so whoever solved the problem, can you just explain why x plus 55 equals z or 2x plus 10? Because there's something really subtle here. Oh, you didn't? Okay. Or you could just have said that since these two are parallel angles, right? And angle BCE is a transversal. So it's basically that uh if you have Z, right? You see that these two lines these two lines are parallel to each other. This is a transversal cutting through the line. So if you notice something that's Z right here, and this Z is going to be equal to this Z right here, uh which are basically why this is because uh like this angle, right, is going to be equal to this angle right here. Do you guys see why? It's because these are correspond. It's because these angles are because these angles are corresponding. Like I noticed. I know it's a bit confusing to I know it's a bit hard to see, but if you see this, if you just see this line, right? See this line and this line. You see that this lies under this parallel line. This lies under, but this also lies under that line. So does that make sense? Like if you just consider this transversal, you see how these two angles are corresponding, and these two angles are corresponding. Like just consider the transversal BE. Yeah. So if you consider the transversal BE, now all we have to do is basically just set z equals x plus 55, right? And I think so if you said x plus 55, you get x equals 45, right? Right? And then basically, then you notice, then all you have to do to find CED is this: you find this angle right here, which is just 45 plus 55, which is 100, right? Right? And then you notice that this is a line. So the sum of these two angles, the sum of this angle and this angle is going to be 180. So so you just basically, now you're done. You just basically subtract 180 from the angle, from the x plus 55 angle, or the 100 angle, and then you get 80. Does that make sense for the most part? I know it's a bit hard to see. I'll try to go over it next time as well, because I think this is a really useful problem about angle chasing that just ties in what we learned the whole class. Does that make sense for you guys? Okay, cool. So yeah, we are done for today. I hope you liked the class. I hope you come back next time. Thank you. You can just, do you have a mic right now? Because we are the only people that are in this room. So you can just speak.
So I noticed that angle CDE also equals 2x minus 20.
Sorry,
Uh,
you're breaking up a bit. So
Oh, hello. Can you hear me now?
yeah. I can hear you.
Okay.
What?
Yeah. So I noticed that angle CDE also is also 2x minus 20.
Mm-hmm.
And then you see the angle DE whatever x plus 55.
Yeah.
Yeah, so to find angle CED, I just subtracted x plus 55 from 180.
Okay. Yeah.
And then it gives me angle CED.
Uh-huh.
And then
Oh, yeah,
yeah,
That's a good way. Yeah.
yeah.
That's
And
fine.
then we're given angle ECD, which is 30. So I just added them all up and equaled them to 180, and then I solved for x.
Yeah. I mean that requires more calculation, I think. But if you do it that way, it's easier to see, but I think it requires more calculation, does it not?
Yeah.
Yeah. So I mean, if you saw the way I did it, like if you saw it when you did it, that's great because it's just a two-step problem then. But if you didn't, then yeah, your way is fine. I mean, if you
Yeah.
do the calculation pretty quickly, then yeah, that's good.
Yeah.
Right.
Also for the uh triangle proof
Mm-hmm.
180.
Mm-hmm.
Yeah, I found like an easier way. If you can go back to that slide real quick.
Yeah, sure.
So
Yeah.
uh
Right.
yeah, so we could also notice that angle JAB plus angle BAC plus angle CAH is
Mm-hmm.
180.
Mm-hmm.
And then since these three angles also equals the angle in the triangle,
Yeah.
they also equals 180
Yeah,
for
yeah, yeah. That's what yeah, that's exactly it. I just didn't have the time to do it because, my internet
yeah.
was being slow. And or
Yeah.
I'll just provide the proof in when I post the Jamboard later tonight.
Yeah, sure, sure. Thank you
Yeah.
for the class, Sid.
Yep, you're welcome. Thank you.
Yeah, thank you. Okay, bye.
Yeah, bye.
Well, also, when will the homework be posted?
Uh, expected, if not today night, then probably not today night, but expected somewhere sometime tomorrow, maybe. Yeah,
Sure, sure. Okay. Yeah, got it.
yeah, great. Thank you.
Thank you. Bye.
Bye.